Hey everybody, welcome back to another fun and exciting algebra class. Today's lesson, 4.5, will be solving absolute value inequalities. Now this is if you look at the book and you're like, oh boy, this is really confusing lesson, I'm going to try to make it as simple as I can for you, but there are some confusing parts to it. So hang in there and we'll try to work through some of those things. We're on page 144 in your book. Look down there at page 144, and like I said, this is a little bit confusing, but I'm going to try to work you through this. Remember that absolute value simply means the distance that a number is away from zero. So for example, the absolute value of 3, it is both positive 3 and negative 3. Why? Because negative 3 is 3 spaces from 0 and positive 3 is 3 spaces from 0. So it is the exact same distance from 0 on either side of 0. That's what absolute value means. So when we're solving these, we have to find both values, the one on the left side of the 0 and the one on the right side of the 0. So let's think through this, right? So let me say that the absolute value of x is greater than 3. Okay, we want to know, how do we solve this? So let's just say randomly that x is 4. Let's say x equals 4. Okay, so is 4 greater than 3? Yes, it's true. But what if we say x equals negative 4? So now the absolute value of negative 4 is greater than 3. What is the absolute value of 4? Well, it's 4. 4 is greater than 3. So both of these work. That's the confusing part of these, is that we have a number that's bigger than it that works, and then we have a number that's smaller than it that also works because of the absolute value sign. Again, we're not dealing with value of number, we're dealing with what's called the absolute value of a number. So because of that, we have to kind of think through some of those things and kind of think in a way outside of the box just a little bit. So let's go back over here. I'm not going to teach you this way. I'm going to teach you another way that's just kind of a little bit more of an algorithmic way, or just kind of, in other words, just learning a certain thing, and we're always going to do it like this. You can solve these. Absolute value of a is greater than k. What is k? K is a constant. K is like the 3. And the one that we just looked at, it was x is greater than 3. So k would be the 3 in this case. K is a constant. Now, if we think through this and we go back over here, and I used x equals 4, but let's use x equals well, we can't use 3, but let's think through 3. Let's say that the number is 3. On the number line that we do, our numbers that matter are actually going to be 3 and negative 3. And those are both going to have circles on them, right? Okay, so think through this. In other words, we're going to have solutions that go up here to the big side of 3, 4, 5, 6, 7, 8, 9, and then over here to the little side, to the smaller side of negative 3, negative 4, negative 5, negative 6. Those also work. So in other words, if we say that x equals 3, okay, then we can also say that x equals negative 3. Now I'm using the equal sign to hopefully make it a little bit easier for you, since we're basically using that for our numbers. So I want you to see something. Notice that if these both work, and if these are both of our numbers right here, I want you to see something. So then the x could potentially equal 3, but the x could also potentially equal negative 3. So when we solve these, here's what we're going to do. We're going to have one that is based on the positive side. So let's write the positive side. X is greater than 3. We're also going to have one that is the negative side of that. In other words, negative x is greater than 3. All right, now, again, I'm trying to show you the way that this works. We would never start off with negative x, would we? Okay, if we would always multiply that or divide that by a negative 1 in order to solve that. If we multiply both sides by a -1, what do we get? We get that x, and we have to flip the sign, is greater than -3. This is the same thing. All of these things work with this because of the absolute value sign. And I know I'm like blowing your mind, but I want you to go back and look at this now. When we have our constant, all we have to say is that we have a positive value of that constant with the original sign, and then we have a negative value of that constant with our sign flipped. I just showed you why you flip the signs, okay? If you will just trust me, and you don't have to do that every time, if you will just flip the sign and put a negative with the constant, you will solve these and you will get the correct answer, okay? All right, let's go ahead and turn the page and let's do some of these. So 145. Let's do some of these with that thought in mind of just flipping the sign and adding a negative to the constant. So what we're starting with is 3x absolute value is less than or equal to 6. All right, I'll change the color on this so you can kind of follow along a little bit better maybe. We're going to do a positive value of this. What's the positive value? 3x is less than or equal to 6. Okay, there's our positive value. Now we're going to do a negative value of the same exact thing. What do you mean, Mr. Steve? What do you mean by that? Well, technically, we're doing a negative value of the 3x. Okay, but because we're wanting to move it to the other side in order to solve it out, what we're going to do is we're going to do a 3x. We're going to flip this sign. Now it's going this way, and we're going to do a -6. In other words, this constant right here, we made it a negative constant. Okay, so go back over here. Go back over here to this. We're using this right here. We're using the top one. This bottom one is a little bit too confusing. I would rather you not use the bottom one. It is a way to do it. Basically, there's two ways to do these. You can do it the way that the top method is showing, or you can do it the way the bottom method shows. And when we come back over here to this first one is done like that bottom method. I'm not going to show you that way. If you want to go to the book and if you want to figure it out, that's fine. But I think that you're going to have more problems trying to solve them this way than you will solving the way that I'm showing you. So if you will, just go ahead and follow along with this and trust me, and you're going to get the correct answer. So on this side, okay, let's talk about this side. This side over here is just the positive value, okay? This side over here is going to be the negative value. When we have the negative value, we have to flip the sign. That's really important. If you don't flip the sign, it's going to be wrong. Okay? And so now we come over here and now we just solve them. Just like you would. Divide by 3, x is less than or equal to 2. That would be one of our solutions. Okay? Now we come over here to the other side and we have the same thing going on. We just solve it like we would. Divide both sides by 3. X is greater than or equal to -2. So those are our two answers. We'd come over to our number line, okay? And we'll put our 0 on here. We'll put our +2 and we'll put our -2. All right, so here's what we're going to do first. We'll do the 2 first, and we'll circle the 2, the +2, and we're going to color that in. Okay, why? Because it's also equal to. Okay, and then we'll do our -2 right here. Circle it, color it in. Why are we coloring it in? Because it's also equal to. And now we're just going to test our points. Okay, let's test the 0 to see if it's in the middle. So 0 is less than or equal to 2. That's correct. Let's try this. 0 is greater than or equal to -2. That is also correct. So this one would be colored in the middle. Okay, and that would be our number line right there. That's our solution. Okay. So once you get it, once you get these absolute values into the inequality, it's going to be the same as we did in last lesson. All right, let's do this one. The absolute value of x plus 3 is greater than 2. All right, we're going to need two of these again, so we'll do a positive one. So the x plus 3 is greater than 2. That's our positive side. And then our negative side, how do we make that negative side? Remember, we're just going to do the k, which is the constant side. We're going to turn that negative, and we're going to flip this sign. So we're going to have x plus 3, flip the sign, and then we're going to have a negative 2. Okay, solve both of those and we will get our answers. All right, solve the first one over here, minus 3 from both sides. And we're going to end up with x is greater than negative 1. Come over here and do the positive side now. And we're going to subtract 3 from both sides. And we're going to end up with x is less than negative 5. Okay. And there's our negative sign. So now what we need to do is now we need our number line, okay? So notice that it's not 2 and negative 2 this time. It's two different numbers, and that's because we had a plus 3 on this thing. And when we have a plus, now if it's just multiply, then you're going to end up with the same. But if you have an addition or a subtraction in there, it's going to move on the number line, which is what this one did. So if we have our 0 here, we have our negative 1 here, and then we have our negative 5 here. These are the important numbers, negative 1, negative 5. All right, something important to remember when we do this is that this is absolute value. So in other words, when we go up here, this would be an or statement. So in other words, you could have the positive or you could have the negative. Either one of them work because it's absolute value. You have a positive side and you have a negative side. So either one of those work. So when we do this, we're going to remember that this is an or. What does that mean? It only has to work in one of them for it to be part of the solution. So if we go over here, and usually our 0 is in the middle, but our 0 is not in the middle this time. So let's pick a number in the middle. So let's go negative 3. Okay, so we'll use negative 3. On this one, we'll use positive 3. And on this one, we'll use negative 6. Okay, so those, I'm just picking different numbers from the number line. So in other words, this part of the number line, I'm using negative 6. This part of the number line, I'm using negative 3 because it's in between our numbers. And then this part of the number line, I'm using positive 3. So we're going to go up here, and it only has to work in one of them. So let's try this one in the middle first. Negative 3 is greater than negative 1. No, that's not right. That's not true. Let's try this one. Negative 3 is less than negative 5. No, that's not true either. So this middle number does not work. Now let's look at negative 6. Negative 6 is greater than negative 1. No, that's not true. Let's use it over here. Negative 6 is less than negative 5. That is true. That works. Because that works, we would color this in. Okay? So that works. It only works in one, but it only has to work in one because this is an or statement. Over here, we would use the number 3. 3 is greater than negative 1. That is true. And so we would use this over here. We would fill this in as well. Okay? So remember those things there when you're solving these. Let me show you one more thing and then we'll be done with this lesson. So now what happens if we get a little bit more complicated inequality? Well, we're going to do the same thing. So if we have 2 and then absolute value of x plus 3 is greater than or is less than 4. There we go. So this is your example from page 145. This is example 4.5b. All right. The first step in these is always getting the absolute value by itself. Notice this 2 out here. I can't start with this 2 right here. I have to divide everything by 2 before we can get started. So I'm going to have x plus 3 absolute value is less than 4 divided by 2 is 2. Now that I have this, now that I got rid of my 2, how do I get rid of the 2? By dividing both sides by 2. Now I can get started with this. How do I get started with this one? Well, I make two different equations, inequalities. Excuse me. So we're going to make one positive, x plus 3 is greater than 2. So that's the positive side of it. And then we're going to make the other one be the negative side of it. So how do we do the negative side? Remember, we flip the sign and we make the k, the constant, the negative. So over here, I'm going to end up with x plus 3. And then we're going to flip the sign and it's going to be negative 2. Okay, then I would just solve those. I'll solve this one first since I'm already over here. Minus 3, cancel. X is greater than negative 5. Come over here to the other one, and I do the same thing. Subtract 3 from both sides. X is less than, and that's going to give me negative 1. So those are my two answers. Now they might tell you that they want your answer with the x in the middle. Okay, so like a kind of a compound inequality here. So what could we do to get that x in the middle? Well, one of the things is this is a little bit challenging right here, because notice on this one our x is on the left, and on this one our x is on the left. So what you have to do to these is you actually have to switch, and you typically start, well, not typically, you do start with the smallest number. So the negative 5 is your smallest number, so you want to start with the negative 5. But when we switch the negative 5 to the other side, we need to, this inequality is the same thing as writing negative 5 is less than x. So x is greater than negative 5 is the same as saying negative 5 is less than x. Okay, so we're going to switch this when we write it back, and then we're going to put x in the middle. Now our x is in the middle, and if you notice here, our x is on the left side, so we would just keep this one the same. So x is less than negative 1. And that's how you put those back into that compound inequality format. So whenever you do that, you'd always start with the smallest number. In this case, it's our negative 5. If you have to switch them, if you had to flip it over to the other side, then you have to switch the inequality when you do that. So to get it into this format, we would take this and we would flip it to give you the less than sign. Okay. Lots of interesting stuff there. Lots of things going on. I know some of you, your minds are probably like blowing up right now, because algebra is supposed to do that to you. Every once in a while, I like to take just a little time out and I like to encourage you. If algebra is not making you think, then algebra is not doing its job, okay? The whole point of algebra is to expand your ability to think. It's to push you to the next level. So if you're getting a headache, if you're not understanding it, you are in good company. A lot of students struggle. But what you have to do is you have to find a way to work through it, to keep pressing forward, and to try to understand. It might not come today, but it might come tomorrow. So you just keep working through this. Watch the video again. Whatever you have to do as you're going through and you're trying to solve these, do your best to just keep pushing forward, keep expanding that ability to think. That's what algebra is for, okay? So hope you learned something there. If you missed anything, slide it back, watch it again. We'll see you later. Have a good one. Bye-bye.